So the standard deviation concept, when we assess, now generally standard deviation is referred as the measure of spread. Now, how much a quantity basically spreads from the average is referred as the standard deviation. Now, let us say if you have a simple data set, let's say 1, 2, 3, 4, and 5. Now, this will have certain average. Now, let's say the average of this value is 1 plus 2 plus 3 plus 4 plus 5 over 5. So this comes out to be, let's say 3. Now, these quantities that we see, they are like not exactly 3. They are like fluctuating from average by a certain amount. So standard deviation or variance that you talk about measures how much a quantity fluctuates from average. So first what we'll do is, let us write down the formula for a quantity that is called as variance. Now, variance is basically defined as sigma xi minus x bar the whole square upon n. So sigma xi minus x bar the whole square upon n. Now, what does xi mean? What does x bar mean to us? So x bar is the average. Xi, these are the individual values like x1, x2, x3, x4, x5. So xi is basically the values. Ideally, I should have written like, okay, it starts from I equals to 1 to, let's say, I equals to 5. So this basically means that it'll be, you're going to do now 1 minus 3 the whole square plus 2 minus 3 the whole square plus 3 minus 3 the whole square plus 4 minus 3 the whole square plus 5 minus 3 the whole square. This sigma means sum. That's why we are adding up each of them. So what we did is we first find out the difference of each quantity from the mean, square it, add, and then you divide by number of data points, which is 5. So here, let's say this point is going to become 0. So it'll be like at the end, variance is going to be, for us, the variance is 1 minus 3 square is, let's say, 2 square itself. So 2 square plus 1 square plus 0 square plus 1 square plus 2 square upon 5. So this is your, this is going to be your variance. And now when you talk about, let's say, the standard deviation, now let's say this value will be 4 plus 1 plus 4 plus 1, which is 10 upon 5. So which is going to be 2. So the variance of this quantity is 2. Now, standard deviation that you define is the square root of variance. So variance, if you take the square root of this, it is referred as the standard deviation. So standard deviation for this quantity will be square root of 2. So what is so special about standard deviation is, if I have a data set, let's say, and generally if let's say this is the average, let's say this is the average point. We'll do more in detail about this when you're doing normal distribution. But if you go one standard deviation away from the mean, so let's say mean minus one standard deviation and mean plus one standard deviation. Standard deviation is represented by the sigma notation. So around 65% of the values will fall in this interval. So if I say that, let's say this is 3 minus root 2 and 3 plus root 2, you'll notice that 65% of these values will fall into that interval. If I go 2 standard deviation away from the mean, which means that if this is like mean minus 2 sigma and mean plus 2 sigma. So if I go 2 standard deviation away from the mean, you will notice that you have 95% of the values, close to 95% of the values will be in that interval. And if you go 3 standard deviation away from the mean, 3 standard deviation away from the mean will be 99% of the values will be in that interval. So this is how is the significance of standard deviation. There is another formula that we can learn, And that formula is nothing but, let's say variance formula is sigma xi square over n minus x bar square. Sigma xi square upon n minus x bar square. So let's say if I wanted to find out the variance in this case, I would just do square each values, add them up, 1 square plus 2 square plus 3 square plus 4 square plus 5 square upon 5 and minus mean square. Minus mean is nothing but 3 square. So whatever this answer comes, so this will be like 11 minus 9. If you calculate this, this answer will be 11 minus 9, which will come out to be 2. So this is how you do the standard deviation. And this will be the variance, and standard deviation will be square root of this. Now, what is really interesting and important is you should know how to do even with the frequency table. So I'm just going to show how is that formula different when you have been given, let's say, frequency table. So let's say I have got the x values. So x values and corresponding frequency has been given. So let's say x is 1, 2, 3, 4. And corresponding frequency is 3, 6, 2, and 5. And I wanted to find out the variance for this. So in such cases, first, obviously, we have calculated the mean. So the mean formula is sigma x times f over sigma f. So sigma x times f will be like 1 times 3 plus 2 times 6 plus 3 times 2 plus 4 times 5 over sigma f, which is 3 plus 6, 9, 9 plus 2, 11, 11 plus 5, 16. So if we calculate this using technology, we get the answer as, so this mean is 2.56. And now when you calculate the variance, now variance formula for this kind of result is sigma xi square times frequency. Now because there's frequency, so sigma xi square upon frequency. Instead of n, we have now summation of frequencies and minus x bar square. So what we're going to do is basically when you find out the variance for this, will be 1 square times 3 plus 2 square times 6 plus 3 square times 2 plus 4 square times 5 upon total frequency is 16. And this answer minus 2.56 square. So x bar square is nothing but the mean square. So this, whatever this answer comes to be, that's your variance. So this value comes out to be 1.258. And if you square root this answer, what we're going to get is like standard deviation, which comes out to be around 1.12. So standard deviation is around 1.12 we get, and this is the variance. So that's how you calculate the standard deviation for a given data set.